For section 5.1, our introduction to graphing, and to introduce graphing, we're going to actually start by looking at what is called linear data. But before we even get into that, let's just talk about what do we do if we have a set of data and we actually want to graph it. And all the data that we're going to look at in this class is going to be real world data. So when you have real world data, you have to figure out which set of data represents your X variables and which set of data represents your Y variable, and how to plot those ordered pairs on the coordinate plane. So what I want to do is I want to go through just some basic steps to graphing data sets and a few examples. So to graph a set of data. So if we want to graph a set of data, the first thing that we're going to do, and I'm going to walk through this in steps and go back and forth between the steps and an example of how to apply each of the steps. So the first thing that we have to do is we have to determine which quantity is the X variable and which quantity is the Y variable. Now, when we have a set of data, it tends to be given to us in a table. So when we have a table of data, the convention is that we put the X variables on the left, the X data set on the left, and the Y data set on the right. Well, why is that? Well, that is because X represents the independent quantity, or we can think of that as the input. That's another way to think of it, as the input values. So X represents the input or the independent quantity, and Y represents the dependent quantity. Or the output values. So it tends to come to us in a data set where X is the first column and Y is the second column, but that's because X tends to be listed first because it determines what Y is going to be. So we sort of think of it, the connection goes this direction, like an input and an output. So if you had 1 here and 5 here, we're saying that when you're given an X value of 1, then the output of the Y variable, the output is going to be 5. Okay, but in the context of real world data, what does that look like? So that's the first thing that we have to do, is figure out what's X, what's Y. So let's come over here, and I have an example set up right here for us to look at. So in this particular example, we're actually looking at dosing. So this example that I want to work through as we do this example is a dosing example. A dosing example. So we're given a data set here, and we're told that for certain weights, a specific dose of medicine needs to be given. So if a patient weighs 65 pounds, then they are to be given a dose of 60 milliliters of medicine, and so forth. And I just grabbed this little Tylenol image just to give an image to go with this. Actual set of data. It has nothing to do with actually the data that's given here. I just grabbed that image along with a set of data about dosing. So if this is our dosing example, we would say from here that X is going to be the weight of the patient in pounds. And that's because weight is independent. It does not depend on the other variable at all. It is also given as in the first column of our data, but beyond that, it is the independent quantity here. So this represents the independent. How much a patient weighs is independent of anything else. So this is independent. Or you can think of it as an input, right? A patient walks into a doctor's office or walks into their medicine cabinet and they have a certain weight, and that's independent of anything else that's going on in the situation. Then the Y is going to represent the second column here, or the dosage. The dosage in milliliters of this medicine. Now that does depend. It depends on how heavy the patient is or what the weight of the patient is. So we say this is Y for many reasons. One, it's the second column in the data set, but also it just depends on X, which is weight. Okay? How much a patient gets of this medicine depends on how much they weigh. So Y depends on X. Now, each of these, and we're going to graph these, each of these sets of data represent an ordered pair. So 65, 60 is an ordered pair. 97 and 70 is an ordered pair. Those two data points are connected. The X and the Y are connected. If you weigh 65 pounds, you get 70 milliliters of the medicine. If you weigh 97 pounds, you should get 70 milliliters of the medicine. So each of these, we won't tend to write out these as ordered pairs, but when we look at this table of data, we do think of these as ordered pairs because we are going to graph them. So the first thing we have to do is figure out what is X and what is Y. That's the first thing that we always do when we come across a data set that we want to graph or represent in any way. We have to figure out what represents X, what represents Y. Okay, so that's the first thing that we do when we're graphing a set of data. Now, the second thing that we're going to do once we've got that figured out is we're going to actually start setting up our graph. So the second step is going to be to set up the rectangular coordinate system. So we are going to come in, and there's a couple things that we have to think about, but I'm going to draw just a generic graph. The rectangular coordinate system has a vertical and a horizontal axis. The horizontal axis is the x-axis, and the vertical axis is the y-axis. So we've done a little bit of graphing before, but just as a reminder, horizontal is our x-axis, vertical is the y-axis. So we start off when we're setting up the rectangular coordinate system, a couple of things to consider. One, we need to always label the axes. So since in the previous step we figured out what x and y are going to be, that's the first step, figure out what is X, what is Y. Then once we get to setting up the coordinate system, we label our X-axis and our Y-axis accordingly. So we label the two axes. Then the second thing we have to make sure we do, and this is very important, is that we use a consistent scale. So we set a consistent scale on each axis so that all the data can be graphed. So we are going to pick a scale so that we can make sure we get all the data graphed, that all the data points will be covered by our scale, and it has to be consistent. Okay, so a couple of things. This is important. It has to be consistent scale and a consistent scale, and we have to make sure that all the data can be graphed. Okay, so we'll do this through some examples, but that is something that we need to make sure of. So what I mean by a consistent scale, when we're setting our scale, we have to make sure that we have consistency. So if a block, a tick mark on the x-axis represents 5, then it must always represent 5. So 5, 10, 15, 20, 25, 30. That's what I mean by a consistent scale. Each tick mark, consistent scale. Each tick mark represents the same within the axes. We can't all of a sudden go now from 30 to the next line. We can't jump and say, okay, now this represents 40, because that means that the tick mark has now gone from representing 5 units to representing 10 units. So we cannot do that. This would have to be 35 if we were going up in a consistent scale. Now, the scale that we use on the x-axis does not necessarily have to be the same scale we use on the y-axis. So for instance, suppose my y range is a lot larger than my x range, and I want to set on my y-axis, I want to set the scale to be in hundreds. I can absolutely do that. I can say 100, so one tick mark represents 100 units. So every tick mark has to represent 100 units. So if this is 100, the next tick mark would have to be 200 and 300 and 400 and so forth. Okay, so the scale does not have to be the same between the x and the y-axis, but it does have to be consistent within the axis. Okay, so it has to be consistent. You have to have a consistent scale within each axis. Okay, all right, so let's take a look. So how are we going to do this? Let's take a look back at our example. So our example had some real world data, and we got to make sure we know what's X and what's Y, but now we want to make sure that we actually get, so let's go back to this dosing example. Now we want to make sure that we get all of the data on the same coordinate system and make sure that our scale spans the whole coordinate system. Make sure that the scale that we pick will span, stuttering over my words, span the whole scale that we need. Okay, so if I look at my X's, so remember that we've already determined that this column represents X, this column represents Y. So in the X column, I notice that the smallest data point that I have, this is essentially the low or the small data point, is 65. And it turns out this is not always the case, but it does turn out that this guy is increasing down the column. So the high is down here at 271. So I'm looking at that data set and I'm saying, okay, I got to make sure that I span the numbers on the X-axis between 65 and 271. And I will give you a little tip. I always give myself a buffer on either side. So I see 65 and I actually think I'm going to make sure I start at least 50. And I got to go all the way up to 271. Why don't I just round that up to 300? So I need to make sure I have a scale that will cover from 50 to 300 on the X-axis. So as I'm setting this up, I'm going to come down here and I'm going to set up my coordinate system. And this is why having graph paper is very helpful in this and future sections. So I'm going to bring a ruler as well, is very helpful. I am always going to start by labeling. That was the first thing, and I jumped right over that and got into the scale. But X is representing the weight of the patient. So I'm going to just write weight, and this is in pounds. And my y-axis over here, my y-axis is representing the dosage, and this was in milliliters. Okay, so again, I need to make sure that I span from 50 all the way up to 300. So as I'm looking at this, I'm thinking, well, I could start at 50. If I don't want to start at 0, I can easily do that on this scale. I just put a little blip, 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 like a little zigzag right here. That means that I've jumped some numbers, and I'm going to start here at 50. And since I want to make sure I get all the way up to 300, I'm just going to go ahead and go in 25. So if that's 50, then I'm going to make this 75. I'm going to zoom in just a little bit, make that 75. I'm going to make this 100, 125. So as I'm going along in my scale, and this is going to be 150, and this is 175, and this is 200, 225, 250, 275, and 300. And I probably could have spread it out a little bit further. I had enough space here, but that works, and I get all of the numbers that I need on the X-axis. And now I'm going to go back and decide, well, what should be my scale on the Y-axis? So it helps to sort of think about what's the span of the data. So look for the low point. So again, along the Y, I notice here that my low point is at 60 and my high point is at 160. And so I think, okay, I can make sure that I span between as long as I'm spanning between 60 and 160. So I think to myself, well, maybe I'll start at 50 and make sure I get up to 200. And maybe I go in on this one, maybe I'm going to go ahead and go again. I'm going to make a little zigzag and I'm going to say, okay, why don't I start here at 50? And why don't on this axis, why don't I go in 50s? But I can do it like this. I can say 2 tick marks are going to represent 50. So this would be 100. This would be 150, and this would be 200, and this would be 250. Meaning there are tick marks in here, these in-between tick marks, which would represent half of that span, which would be 75 in this case, and so forth. So I can sort of think of going up like that. I actually do actually have the same scale that I chose on the X-axis as I do on the Y-axis, but that's just in this case. Okay? It doesn't have to be that way. 225 here. So I could add those in if I needed to. Okay, so now I have picked a scale. I've labeled my X-axis and my Y-axis. And so now we're actually going to plot the points. So once we've set the rectangular coordinate system, the next thing that we want to do, the third step, is to actually plot all of the ordered pairs. So once we have our axis, now we're going to go ahead and go in here and we're going to plot the ordered pairs from from the data. So from the data set given. And again, this is going to be, we're working with real world data, so this is going to be approximately as close as we can get. Okay, so we're actually going to use some technology here in a couple of sections to graph these data points exactly into a coordinate system. So this is going to be the best that we can get. We're going to get as close as we can. So we're not going to get too fixated on having the exact point or being exactly where that ordered pair should be in the rectangular coordinate system, because this is all real world data. So that could take us a long time, and we're never going to be exactly on in our hand-drawn graphs. But we'll get as close as we can. Now, I'm going to go ahead and write one more step so we can do it all at once when we go over to the example. And the fourth thing that we're always going to do once we've got all of our data graphed, what we're going to actually do once we have all the data graphed is we're going to pull back and we're going to look for a trend. Okay, so we're going to now, after we get the data graphed, this is the whole reason we're graphing the data, we're going to look for a trend, what is called a trend in the data. So we're going to look for a trend. And what I mean by that is there some sort of trend? Is there some sort of pattern that we can recognize, something that we can capture mathematically? So is there a pattern in the data that can help make future predictions? Future predictions. And that's what we're spending the rest of the whole semester looking at, is getting data graphed and initially just looking at that graph and saying, is there something here that I can capture mathematically? Is there something that appears to be a pattern or a trend in the data that I can use to make future predictions, or even maybe backward predictions? I can think back and use the data maybe to talk about what has happened in the past. So that's what we're going to do with the data once we have it. We're going to look for the trend. In this chapter, we're going to look for, so in chapter 5, we're going to look for linear trends. So in chapter 5, we're going to look for linear, straight line trends. So we are going to be looking for, when we talk about a linear trend, does the data trend upward or does the data trend downward in a linear fashion? So these are linear trends. So that's what we're going to be looking for in chapter 5, and then we'll get into other types of trends in future chapters. But the general idea of graphing will be the same even in the future chapters. It's just when we get to the trend, it'll be a different sort of trend we'll be looking at. Okay, so let's go back and let's actually get our graph plotted for that dosing example. So here is our dosage example. We've got the scale, and now I just need to plot the ordered pairs. And because I think it would be a lot easier if we actually had this guy down below, I'm going to scooch this over here so we can actually use it. It's the beauty of, you can't do that on a whiteboard. This is the beauty of actually having a tablet that I can move things around on. So I'm going to go ahead and just put this kind of over here to the side, and we're going to use that as we're plotting the data, and then I can move it when we get, oh no, we'll be okay if we leave it right there. So I'm going to leave that right there just so that we can see it all on the screen at the same time, and we're going to plot this data. So now we're going to plot each of those ordered pairs. Again, not an exact science, we're just going to do as best we can. So if we've got 65, 60 is the first ordered pair. So on the x-axis, I'm going to go to 65. So if this is 50, 55, 60 would be kind of about here, and the dosage for that person would be 60. So that first ordered pair is going to be plotted right about there. And then the next one is going to be 97, so just a little bit to the left of 100, and at 70. So 97 and 70 would be right here, a little below 75 on the y-axis. 97, 70, and we keep going. So 125 and 80. So 125 and 80 would be about right here. And 156, so a little to the right of 150, and 100 would be right here. Okay. And 190 and 120, so 190 and 120 would be about here. 232, so 232 and 140 would be about here. getting that plotted, and 271, so 271 and 160 would be right about, probably about there, okay? Okay, so once we've got all of the data graphed, we can see here that there's a definite clear linear trend. Now, we're definitely going to look at some examples where it's more of a scatter plot than this particular one. And we'll have to zoom out a little, and maybe the trend isn't quite as obvious as this, but I would definitely say this first example that we've done here is a very clear linear trend. It's not about connecting the dots when we go to draw in a trend line. When we draw in the trend line, you're going to want to grab a ruler. And once we grab the ruler, you're going to want to spin the ruler, and I'm using my virtual ruler here. You're going to take your ruler by hand, and what you want to do, notice that the dots don't all connect exactly with my ruler, but that's not actually what I'm looking for when I'm drawing in the trend. When I'm drawing in the trend, what I'm trying to do is I'm trying to connect the general trend of the data. So notice here, and you can see a little bit through my ruler here because it's a little opaque, a little see-through, that some of the data points are below the ruler line and some are just a little bit above, and that's exactly what I'm looking for. What I want to do when I come in here is I want to actually draw in the general trend of this data, not the exact. Certainly don't want to zigzag. I just want the trend of the data. And so when I remove the ruler, what you can see here is I have created a linear trend. This is definitely a linear trend line. It is what we think of as the best fit. So it's the best fit that I could get using my ruler, and it gives me the general sense of what's happening on the graph. I can use that trend line. So it's a best fit. Okay? Definitely a best fit, not a connecting of the dots. We don't want zigzag lines where you just connect the dots. We want a best fit. What's the general trend? And once I've got that general trend, I can use this general trend to do all kinds of things. Like, for instance, if I wanted to know about what dosage should I give a patient that weighs 300 pounds? Well, 300 pounds right here on the x-axis would come up here. I can use my trend line and I can say, well, they should get, notice that this ordered pair right here would be about 300 and, I don't know, 170. It's just a little bit above 178.5. So maybe I say 178. So we could say a patient, if you have x equals 300 pounds, that would generate a dosing, a Y value of about 178 milliliters. So we can use the trend, so that's using the trend line, use the trend to make predictions. And that's exactly what we're going to do with our trend lines, to make predictions. To make predictions or estimations, and that's what we want to do once we've got these trend lines graphed. So that is the general idea of when we want to actually graph a set of data. Those are the steps that we're always going to follow. I know this was a long example here, but this would have taken me a little bit of time in class to lecture on this, and so I wanted to get this all on one video. So just to reiterate, that when we graph a set of data, the first thing we're going to do is determine what is our x and what is our y. Then we're going to set up a rectangular coordinate system where we've labeled the axes and we have a consistent scale on each axis so that we can graph all the data. Okay, so we got to make sure we give ourselves a little bit of a buffer and make sure we span the entire data set. Then we plot all the ordered pairs, get as approximately as close as we can, and then we look for a trend. And we're going to say in this chapter, we're going to be looking for linear trends. Does the data trend upward or does the data trend downward? And we're going to use our rulers to get a line of best fit. Okay. That is the general theory behind 5.1. I have one more lecture video and another example video that I'm going to go ahead and make for you guys. So please take a look at both of those as well.